Uh, Good morning, students. Today we have to discuss about other two factors of reversible, isothermal reversible expansion of van der Waals gas. We already discussed delta U, change in internal energy. We also derived it, which is equal to minus n square A 1 by V2 minus 1 by V1. V1 is the initial volume, V2 is the final volume. We also derived work done, W is equal to minus nRT ln V2 minus NB divided by V1 minus NB minus n square A 1 by V2 minus 1 by V1. We derived these two equations already in the previous video. Today we have to discuss about how we expression for Q, heat, expression for Q, expression for Q. From the first law of thermodynamics, from the first law of thermodynamics, it is known that del Q is equal to du. Here is the expansion. That means from the first law we know that P dV by W. This is also which is called W. That means del Q is equal to du plus W. This is the we know. Then you take du in one side. Then del du is equal to del Q is equal to du plus W. But here we have to W is negative because here the work done by the system. It is written that undergo expansion. Reversible, isothermal, reversible expansion of an van der Waals gas. Expansion means become minus W. That means my del Q is equal to du minus W. We have to write because the work done by the system, some energy decreases, undergo expansion. Now in order to find out del Q value, put the value of delta U and put the value of W here. And what we get, now del Q is equal to, here is du. Du means this one, minus n square A 1 by V2 minus 1 by V1. Du del Q means du is a small change, del U means large change. That means you can also write this one del Q by Q or Q is equal to del U minus W also you can write. So in place of del Q must change in, or you can write Q. Del U minus W. Minus W means this is the del U. Del U we already derived it, minus n square A 1 by V2 minus 1 by V1. Then W is this one, minus of W, minus minus plus, so it becomes nRT ln V2 minus NB divided by V1 minus NB. Here minus, minus plus, which is equal to n square A 1 by V2 minus 1 by V1. Here you see minus n square A 1 by V2 minus 1 by V1. Here also it is cancelled. We get what? Now del Q or Q, which is equal to minus n R T ln V2 minus NB divided by V1 minus NB. This is called as the del Q. This is the expression for del Q or Q. This is the expression. Then what is the expression? Then expression for delta H, enthalpy. Then we have to find out expression expression for delta H. Formula we know, enthalpy is equal to initial state H1 U1 plus PV1. Pressure is constant, it will not change. Enthalpy means heat content in a system at constant pressure and temperature. That is called enthalpy. Definition: heat content in a system at constant pressure and temperature. So pressure is constant. This is the initial state. Final state is H2 is equal to U2 plus PV2. This is the final state. Then what is the change in enthalpy? Final minus initial. That means delta H is equal to H2 minus H1. H2 means U2 minus U1. U2 minus U1, make it bracket, plus PV2 minus PV1. Do not take P common. If you take P common, nothing wrong. But we have to put the P value of the van der Waals equation here. That means this one is nothing but H2 minus H1 is nothing but delta H. This is nothing but delta U. But this is PV2 minus PV1. We know delta U is equal to this one. We already derived. So before that we take the P value of the van der Waals equation. The van der Waals equation is P plus N square A by V square whole of V minus NB is equal to nRT. That means I need this one. Take this one to this side. Then P plus N square A by V square हेले nRT by V minus NB. Then P is equal to nRT divided by V minus NB. Take this one to this side. Minus N square A by V square. This is equal to P. Here you see it is PV2. So in place of V, I write V2. So in case of PV2, what is the value will come? nRT divided by V2 minus NB minus N square A by V2 square. Then PV1, we take the PV1. PV1 is equal to, in place of V, I write V1. nRT divided by V1 minus NB minus N square A by V1 square. Now put this PV2 value and PV1 value here and delta U value, this delta U value here. Then you get delta H. Delta H is equal to delta U value, I put this value here, delta U minus N square A, N square A 1 by V2 minus 1 by V1. This is delta U. Then plus PV2. PV2 value this one. nRT divided by V2 minus NB minus N square A by V2 square. P to PV2 minus PV1 minus PV1 this one. nRT divided by V1 minus NB. Here is PV2 minus PV1 minus plus N square A by V1 square, because PV here is delta U. Delta H is equal to delta U. I put this value of delta U here, minus N square A 1 by V2 minus 1 by V1. Then PV2 is equal to this one, nRT by V2 minus NB minus N square A by V2 square. Then minus PV1 minus nRT by V1 minus NB. Then minus, here minus plus minus N square A plus N square A by V1 square. Then your delta H is equal to minus N square A 1 by V2 minus 1 by V1. Take, you do one thing. Here you take from these two, you take nRT common. These two. From these two you take nRT common, nRT common. When you make common, you get what? Here is P plus NV minus NV. When you take nRT common, 1 by V2 minus NV, a minus 1 by V1 minus NV from these two. Now from this you take n square A common, plus you write n square A common, you get 1 by V1 square minus 1 by V2 square. You see here, here n square A 1 by V2 minus 1 by V1. Here n square A 1 by V1 square minus V2. Just reverse it. When you reverse it, it becomes minus. Then your delta H now become minus n square A 1 by V2 minus 1 by V1 plus nRT you take common, you get, here is nRT, 1 minus by V2 minus NB minus 1 by V1 minus NB. And here you reverse it. This one take this side, this one take this side. So minus will come, minus n square A 1 by V2 square minus 1 by V1 square. This here n square A 1 by V2 minus V1 square, 1 by V2 square minus V1 square. These are all are square. These are all are 1 minus, put it somewhere, mistake. N square A minus B square, delta U. Delta U, we already derived it. You see, delta U n square 1 by V1 minus V2. Same thing, 1 by V2 minus V1. But here it comes, here something P plus n square A by V square, B minus NB is equal to nRT. P plus n square A by V square, nRT minus B, n minus B. Then, I did a mistake. Here. Okay. I did that mistake. So here you get P plus n square by V square nRT by V minus NB. Your P becomes, take this one to this side, nRT divided by V minus NB, take this one to this side, minus n square A by V square. N square A by V square. This is equal to P. Now we have to what? Now suppose you take PV. You take PV. PV means you multiply V here and this side also. We get what? nRT multiply with V. Then V minus NB minus n square A by V square multiply with V. Because both sides you multiply this V square, one V is cancelled. Now your PV is equal to nRTV by V minus NB multiply with V, then here minus n square A by V. This is equal to PV. Now you take, I need what? We need PV2, we need this PV2. This PV2 is equal to, in place of V, I write V2. That means it becomes nRT V2 divided by V2 minus NB minus n square A by V2. Okay, this is PV2. Then we need PV1. So your PV1 becomes nRT V1 divided by V1 minus NB minus N square A by V1. Okay. Now put this value. Delta is equal to delta U PV2 minus PV1. Your delta H is equal to delta U. Delta U means I write that side. Difficult. Okay. I write that this one is delta U. Minus n square a 1 by v2 minus 1 by v1, then plus pv2. Pv2 is this one. Take n r t v2 divided v2 minus nb minus n square a by v2, then pv2 minus pv1. This one is minus pv1, this is pv1. Take pv1 minus nRT v1 divided by v1 minus nb, minus minus plus n square a by v1. Now you take nRT, you take common from these two, you take nRT common, these two you take n square a common. Then what you get? You will get, I will write here again, delta H. Delta H is equal to is minus n square a 1 by v2 minus 1 by v1. Take nRT common. nRT common. We get what? Now v2 divided by v2 minus nb, then minus v1 divided by v1 minus nb common, then minus n square a common, minus n square a common. We get 1 by v2 minus 1 by v1. Okay. From this equation we get this value. Now you see here, this one is same, minus, here you see that you take n square a common, minus n square from these two, take minus n square a common. When n square a common, we get 1 minus minus n square a common, then 1 by v2 minus 1 by v1, minus minus will plus. Now minus n square a common, 1 by v2 minus minus. Okay. Now see, both is same. Both are same. So what we do? Now this will be mixed. We get delta H is equal to what? Now minus delta H is equal to minus 2 n square a 1 by v2 minus 1 by v1. Okay, this one mixed, minus etiki. Then plus, here you take nRT, you have to do what? Now v2 minus nb you take plus nb. No problem. v2 minus nb, in this case minus nb plus nb cancel. Then minus v1 minus nb again plus nb. No problem, it will cancel, divided by v1 minus nb. Okay, now your delta H will be equal to minus 2n square a 1 by v2 minus 1 by v1 plus nRT. Now you make this type of curling bracket, v2 minus nb divided by v2 minus nb plus nb divided by v2 minus nb. I split this one. I take this one. One is this one, then another is this one. This one by this one, this one by this one, same. Then minus, I take this one by this one by this one. V1 minus NB divided by V1 minus NB. Here it is N plus NB by thick, then I write here minus will be NB by V1 minus NB, calling bracket N. Okay, this thing is cancel. Then we get this one by this one. Then delta H is equal to minus 2n square by A 1 by V2 minus 1 by V1 plus nRT common. This one cancel. This one cancel. This one cancel. We get 1 plus NB divided by V2 minus NB. It is also cancel. Minus 1 minus NB divided by V1 minus NB plus 1 minus 1 cancel. From this you take NB common to this side. You get delta H is equal to minus 2n square A 1 by V2 minus 1 by V1. Take NB common. NB common means when you take NB common, nRT, then NB you take common. What we get? Now 1 by V2 minus NB minus 1 by V1 minus NB. N square, nRT B. Then your delta H is equal to minus 2n square A 1 by V2 minus 1 by V1. Now it becomes n square R T B whole of 1 by V2 minus NB minus 1 by V1 minus NB. And this is the expression for delta H. This is the expression for delta H. So now it is over. Which one? Isothermal reversible. Reversible means maximum work where it is performed. It is a theoretical concept only, because we do not find out any reversible 100% reversible reactions. It is a theoretical concept. So it is the isothermal reversible expansion of van der Waals gas. Then we have to discuss about isothermal irreversible expansion of van der Waals gas. Isothermal means you have to keep temperature constant. Irreversible means all reactions in our nature is irreversible. Whatever we do, it is irreversible. Human aging is irreversible. It cannot be come back. When you taking foods, it is irreversible, because the food will not again generated from your stomach. Whatever, suppose I am writing here, ink is over. That means ink cannot be enter into my lid. So in that case, all reactions, whatever you do in the experiment, in our nature, all are irreversible. So we have to find out isothermal irreversible expansion. That means less volume to higher volume. Gas will expand. That means this is V1 initial. But when it undergo expansion, this piston will move upwards to this position. This is equal to V2. So this is the final volume. This is the initial volume. So initial to this is called expansion. That means work done by the system. So we will do again the same for expression for W. Expression for W. How we find out? W means work done. In case of irreversible process, we know that del W is equal to minus P external dV. This is the work done formula. Minus sign because it undergo expansion. Work done by the system. System's energy decreases. You have to remember this one. This is my system. This is the work done on the system, positive. This is the work done by the system, negative. So work done by the system, that is why negative, because system's energy decreases. Then we can write that del W is equal to minus V external from final volume minus initial volume V2 minus V1. This is called irreversible work done. This is the expression for irreversible external. This is the external pressure. Irreversible work done. Then expression for U. This is the expression for W. Then expression for U. U means delta U means change in internal energy. Same time, same process we have to do what we do in the reversible process. U is a function of volume and temperature. Then du is equal to dou u by dou v constant temperature dv plus dou u by dou t constant volume dt. Then from the first law of thermodynamics we know that del q is equal to du plus w. W means pdv, or you take du in one side and you take del q minus w. Minus w means pdv. We know that entropy ds is equal to dq by t, del q by t. Then T ds is equal to del q. Now substitute this del q value here. We get what? Now du is equal to Tds minus Pdv. Now differentiate with volume at constant temperature. Du by dv at constant temperature. That means it dou. Because two variables v and t, we only vary with one variable, that is why it is dou. Dou u by dou v constant t is equal to t dou s by dou v. Dou s by dou v at constant temperature minus p, because dou v cancel. Okay, then applying the Maxwell's relation, Maxwell's relation, what we know? Now dou s by dou v at constant t is equal to dou p by dou t at constant v. Is both are same. So in place of dou s by dou v, I write dou p by dou t. Then dou u by dou v at constant temperature is equal to t dou p by dou t at constant v minus p. This is one. Then from the van der Waals equation we know that p plus n square a by v square v minus nv is equal to nRT. That we know. Now you take this one to this side, take this one to that bottom of this one. P plus n square a by v square whole of nRT divided by v minus nv. This one take to this side. We get what? Now p is equal to nRT divided by v minus nv minus n square a by v square. Here you written dou p by dou t, constant volume is constant. Dou p by dou t, what is the value? Now dou p by dou t at constant volume, you differentiate with v, t, differentiate with dou p by dou t, t, n constant, r constant, v constant, nv madha constant. So nr by v minus nv, dou t by dou t 1. Here is n constant, a constant, v constant, all are constant, so it is 0, minus 0. That means it is equal to nr by v minus nv. Now substitute this value here. We get what? Now dou u by dou v constant temperature is equal to t. Dou p dt, we put this value nr by v minus nv. Then minus p, in place we put this value p, this is the p value, van der Waals equation, minus nRT divided by v minus nv. This is the minus plus n square a by V square. This one nRT V minus NV, this one cancel. We get what? Dou U by dou V, constant temperature is equal to N rho square A by V square. Now this is all a derivation, you have to practice it, otherwise you will make mistake. Then what we get? Now we get dou U by dou V, constant temperature, dou U by dou V at constant temperature is equal to what? N rho square A by V rho square. N rho square A by V rho square. Now my equation, I write this equation once again, so it is easy for me to apply, because we know that again you write U is a function of V and T. Then your du is equal to dou U by dou V at constant T dV plus dou U by dou T constant V dt. Isothermal process. In case of isothermal process, dt is equal to 0 because temperature is constant. dt is equal to 0 means this one is equal to 0. 0 multiplied with this entire thing will be 0. We get only this one. Then du is equal to dou U by dou V. Dou U by dou V, constant temperature. Dou U by dou V, constant temperature is equal to this one. I write this one. Dou U by dou V dV. We get what? Now N square A by V square, dou U by dou V, constant temperature. Dou U by dou V, constant temperature is equal to this one. So instead of this, I write this one into dV. Okay. Now you integrate. Integrate du from U1 to U2, because absolute value we cannot determine. We determine only change in enthalpy. N is constant, A is constant. We take outside N square A integration dV by V square. Value is V1 to V2, initial volume to final volume. Take this one to the above. We get du means U. When you integrate, this is lower limit, then upper limit, N square A. Then you take integration V1 to V2, V minus 2 dV, which is equal to U2 minus U1, upper limit, then lower limit. We get N square A. Then V2 integration is minus 2 plus 1, minus 2 plus 1. Minus 2 plus 1, minus 2 plus 1. That means V minus 2 plus 1 divided by minus 2 plus 1. Then value is V1 to V2, or low initial volume to that of the final volume. Okay. U2 minus U1 is called delta U, change in internal energy. N square A minus 2 plus 1 LA, V to the power minus 1, minus 2 plus 1, minus 1, here I put minus, then value becomes V1 to V2. What we get? Now delta U is equal to minus N square A, V to the power minus 1 means 1 by V. Then we get upper limit first, 1 by V2 minus 1 by V1. Again I derive this internal energy. It is same both in isothermal reversible process and isothermal irreversible process. Change in internal energy will be same. Then again we have to expression for Q. This is the expression for U. Expression for Q. Expression for Q. Q means, from the first law of thermodynamics, we know that Q is equal to delta U. Here is the work done by the system, so minus W. That means now you put this value, Q is equal to delta U. In place of delta U, put this value minus N square A 1 by V2 minus 1 by V1. This is the delta U minus W. W is the previously we did it. My W is equal to, here you see, W is equal to P external V2 minus V1 minus. So here minus becomes plus, is equal to P external V2 minus V1. Now this is the expression for Q. This one is the expression for Q. Then expression for delta H. By expression for delta H केते टाइम अधिक आइजिवो पठे हबनी 35 मिनिट लगानी हो. Okay, I will end here. I will end here. Next class we have to do delta H, then we go free expansion. This is the reversible first one, this is the irreversible, then next one is free expansion. 3. Then in the all the 3 we have to find out W, U, Q and H. So these 4 things we have to find out in every process. We take the reversible process, this is the irreversible process, next coming is the free expansion. Okay, thank you.